Hello everyone, my name is Prashant Sharma and you are watching RoboCircuits. In this video, we are going to learn how we can connect two ESP32 with one another using a protocol named as ESP NOW. ESP NOW is a really basic Wi-Fi protocol in which one of the device transmits its data and the other catches it. Today we are going to make one of the ESP as a master device and one of the ESP as a slave device. Then, whenever we will press the boot button on the master device, the LED on the slave device will turn on, and whenever we again press the button on the master device, the LED on the slave device will turn off. This will be the prime motive of this video to teach you how ESP Now works and how you can create multiple projects with it. And this video is sponsored by LTM 365. More on this later in the video. So without wasting time, let's get started. First of all, we have to connect both of the ESP32s to our computer. So here I have two data cables and let me connect these to my computer. So here I have connected my ESP32 number 1 and ESP32 number 2. So let's get to the computer screens and check what we have to upload. Now we have opened our Arduino IDE. Now let's go to File, Examples, ESP32. Then we will find ESP Now. So here we have to open two codes. One of them will be master. And let's open another window. Let's go to Files, Examples, ESP32, ESP Now, and now we will open ESP Now Basic Slave. So these are our two projects which we have to upload to ESP number 1 and ESP number 2. So as you can see, the left one is the master code and the right one is the slave code. So first of all, we will upload these codes as it is to our ESP32s, and let's check what the serial monitor say. The code of the master device has been uploaded. Let's open the serial monitor, and now the code on the slave device is also uploaded. Let's open its serial monitor also. Now as you can see, last data packet sent to this number and delivery is successful, and you can see here on the slave side we are getting the data. We are getting 3, 4, 5, 6, 7 in data like this. Now let's see how this code is actually working. So whenever we are reading a code, we have to first start from the setup function. So this is the setup function. So first of all, we have initialized the serial monitor. Then we have initialized the Wi-Fi in station mode. Then we have set the Wi-Fi channel, and after that we have printed the MAC address. Now then we will initialize our ESP Now, and once the ESP Now is initialized, we will register a function named as onDataSend. So whenever our ESP will send a data, then this function will run. In the loop section, first of all, we will scan for slaves. We will scan how many slaves we have, and then we will get the MAC address of that slaves. Whenever we get a slave and it is already paired, then we will send the data using this function, and if the slave pairing is failed, then we will write the slave pairing failed. So this is the basic code. So let us first check how the send data function is working. So whenever we want to go to any function, just right click and click on go to definition. So this is the send data function. First of all, we have initialized a variable named data. Then whenever this function runs, we do an increment in this data. Like in the really start it will be 0, then it will be 1, 2, 3. So then we will get the slave address using slave.peeraddress function, and then we will send the data. And after sending the data, we will check if the data is successful or it is not initialized or anything like this. So this is the basic function of how to send a data. Now let us check on the slave side how the code on the slave side is working. First of all, we will go to the setup function. In the setup function, we have initialized the serial monitor. After that, we have initialized the Wi-Fi, but this time we are not in the station mode. We are in the access point mode. That means the slave will create an access point and the master will connect to it using station mode. Then we will configure the device access point and we will print our MAC address. After that, we will initialize the ESP now, and here we will register a function named as onDataReceive. Whenever the ESP now will receive a data, this function will run. So whenever we receive a data, we will receive the MAC address, we will receive the data and the data length. So we will print the MAC address like this. Then we will print last packet received from and the MAC address and the last packet data received. So here you can see last packet data received from, and we have printed the MAC address and we have printed the data. So this is how the ESP now is working on both the ESP32. Let us see what can we do with it. So we have checked out that our master is sending data to our slave. Master is sending data in increment format, like it starts with 1, 2, 3 and goes on like. So now the purpose of this project is whenever I press the boot button on my ESP32 number 1 or my ESP now master, the LED on the slave should turn on and turn off simultaneously. So what we can do? So first of all, we have to read the button status of our ESP number 1, and then we have to send the data accordingly, and whenever we receive the data, we have to turn on or turn off the LED. This is that simple. Let's get to the computer screens and program it once again. Let's talk about the sponsor of this video, Altium Designer. Altium Designer, the industry's leading PCB design software, offers a comprehensive platform for creating innovative electronics. With features like powerful schematic capture, advanced routing tools, and real-time collaborations, Altium Designer streamlines your design process. With Altium 365, you can securely store and manage design files, access them remotely, and collaborate in real time with team members and stakeholders. Whether you are working on a PCB layouts, schematics, or firmware development for your ESP32 projects, Altium 365 ensures that everyone stays connected and productive. And the best part is, if you go to the link in the description of this video, you will get 1 month free and 25% off on your first purchase of Altium 365. Thank you Altium, and thank you all for supporting this channel. So let's get back to the work. In the master side, we will start with pin mode, and you know the boot pin on the ESP is pin number 0, and we will set it as input. So we have set the boot pin as input. Now we will create a variable to store its data. So first variable will be integer button status. We'll start at 0, and integer last button status equals to 0. Now, first of all, we will check for the button current status. If the last button status is 0 and current is 1, that means we have just pressed the button. We will start counting. Then the last button status, whenever the last button status is 1 and the current is 0, that means we have just released the button. We will minus the start time from the current time, then we will get how long the button has been pressed. If the button is being pressed for more than 30 milliseconds, then it means we have pressed the button properly. Then we will scan for the slaves. If we found a slave, then we will pair with it, and whenever we will get paired, we will toggle the current status. That means if it is 0, we will toggle it to 1, and if it is 1, we will toggle it to 0, and then we will send the data. If the button is not paired, we will print the slave pair failed. If there is no slave found, we will print no slave found. And after that, we will change the last button status like this and pressed count to 0. And we will give a delay of 300 milliseconds so that our ESP doesn't get too much load. Let's start uploading this code and let's check what the slave have to say about it. Oh, whenever I will press the button on the ESP32, it will send a data, and currently it has sent 0. Whenever I again press it, it will send 1. Whenever I again press it, it will send 0. And in this way, we can send the status of the button to the other ESP32. Now, let us check what we can do with it. So in this variable, this is the variable where we will get the data from the ESP32. So the LED pin on the ESP32 is pin number 2. So first of all, we will set the LED pin number 2 as output. So in order to do that, we have to write pin mode pin number 2 as output. So pin number 2 is output now. So the data which came to us was in integer form. So we will write it like this. So we are going to digital write on to the pin number 2 the data which we have sent, and I am converting it to integer form. It will work like the way it is, but still I am converting it. You can use it directly like this also. So now let us upload the code and check how these things are working. So the codes have been uploaded. So this is the master ESP32 and this is the slave ESP32. Whenever I will press this button, this should send a data to this ESP32 and the LED on the ESP32 should glow up. Let us test it. Okay, so the LED has glowed once more. It is now turned off, turned on, turned off. And this thing is working really fine. So in this way, you can use two ESP32 to communicate with one another, and we can create cool projects with it. Like I can attach this thing with a relay and I can turn on and off my home lights using this button. So maybe in next video, we will make a home automation project using ESP Now, where we will create an ESP button so that we can control our home lights using a button. So this was it for this video. Thank you for watching. If you like this video, hit the thumbs up button. If you really love this video and you are not subscribed to the channel, please subscribe to the channel. If you have any doubts, you can leave them in the comment section. Thank you for watching and have a nice day.